नमस्कार दोस्तों, मैं शिवानंद उपाध्याय आपका स्वागत करता हूं हमारे YouTube चैनल केमिस्ट्री एकेडमी फॉर IIT JEE एंड नीट। आज मैं सॉलिड स्टेट का एक इम्पॉर्टेंट टॉपिक डिस्कस करने जा रहा हूं जिसका नाम है क्लोज पैकिंग इन 2D। यह टॉपिक इसलिए इम्पॉर्टेंट है क्योंकि हमें यदि किसी भी 3 डायमेंशनल क्लोज पैक स्ट्रक्चर को समझना है तो 2 डायमेंशनल क्लोजेस्ट पैक की ज़रूरत पड़ती है। इसके साथ ही JEE एडवांस 2003 की इस कॉन्सेप्ट पर बेस्ड प्रॉब्लम भी हम डिस्कस करेंगे। दिस इज पार्ट 2 ऑफ क्लोज पैकिंग इन 2 डायमेंशन। इन दिस वी आर गोइंग टू डिस्कस JEE एडवांस प्रॉब्लम by 2 methods. This is one of the problem where teachers and students found difficulty to solve it. So let us solve the question asked in JEE Advanced 2003 based on the concept of close packing in 2 dimension. So we are reading the question first. Marbles of diameter 10 mm each are to be arranged on a flat surface so that their centers lies within the area enclosed by 4 lines of length 40 mm. Sketch the arrangement that will give the maximum number of marbles that can be enclosed in this manner and deduce the expression to calculate it. So the first thing in this question is use of mathematics. They are saying that we have to place maximum number of marbles in an area whose edge length is 40 mm, right? So we have to cover or enclosed an area by 4 lines whose length is 40 mm. There are two possibilities. One can be a rhombus and the other can be a square, right? So we have to, since we have to place maximum number of marbles, if the edge length is same, square has maximum area, so we have to choose a square. In place of rhombus, the area is less, so our first choice to the maximum number of marbles should be a square. So what we have to do is we have to make a square whose edge length is 40 and we are placing marbles inside this, and we have to place maximum number of marbles. So we know that in 2 dimension, if we are placing maximum number of marbles, we'll choose hexagonal packing of 2 dimensions. So we have tried here in this figure hexagonal packing. So this is the A layer and the B layer is placed just between the gaps of A layer. So 6, 7, 8 and 9 in the gap of 1 and 2, 2 and 3, 3 and 4 and 4 and 5 and so on. So now we have to make an square. So we are interested in the distance between A and B layer, because this distance is not equal to 2r. If we are just placing A layer and B layer is just below A layer, exactly matching the position of 1 and 6 atom, then we can say the distance is 2r. But first we have to calculate what is this distance. So in order to calculate this distance, what we are doing, that we are taking circle number 1, 2 and 6. So 6 is at A position and 1 and 2 is at C and B position. Now we are trying to find this distance. So we are drawing a perpendicular from point A on BC. So this is angle bisector also. Since it is an equilateral triangle, this angle B is 60 degree and angle A is 60 degree, but the line AD is dividing. It is an angle bisector, so this angle DAB is equal to 30 degrees. So if we try to find out what is AD, we can write that AD is equal to AB cos 30 degree. So we can write here that this is equal to AB cos 30 degree, and AB is equal to 2 times of R and cos 30 is equal to under root 3 by 2. So if we simplify, we can write that this value is equal to under root 3 times of R. Now we have to make a square whose edge length is 40, and we have to make this square with the help of this type of layer, AB type layer. So the distance between A and B layer we know. So how many such layers we have to place? In order to calculate that, we can divide the edge length of a square by the distance between AB layer, which is equal to AD. So if we put the value, the edge length of the square is 40 and the distance between AB is known as AD, which we have calculated, that is equal to under root 3 times of R, and the value of R is 5. So if we put the value, we'll get that this value is equal to 8 by under root 3. And on simplification with the help of calculator, we are finding this value is equal to 4.62. So this is the value. Now we know that we have to place 4.62 times AB layer such type of layer to get a square, right? Now we have to calculate the number of marbles in the whole square. So what we are doing, that we are calculating how many number of atoms are there between A and B layer, and then we'll multiply it by a factor of 4.62 in order to get the number of marbles in the square. So the number of marbles in A layer, the atoms present at the corner or the marbles present at the corner number 1 and 5 is 1/4 inside the square. So we can say that there are 2 marbles in A layer whose contribution is equal to 1/4. There are 3 marbles whose number is 2, 3 and 4 whose contribution is half. In the B layer we can find out that there are 4 marbles whose contribution is half. So if we simplify this, we are getting this is equal to 4. So 4 into 4.62, if we simplify that on multiplication, we are getting that this value is equal to 18.47. This value is equal to 18.47. So this is the first method by which we have solved this problem. I think the second method is more easy. So let us solve the problem by method 2. Use concept of packing fraction for maximum packing. We should use hexagonal packing of 2D, right? So we have to use hexagonal packing of 2 dimensions. So we know that in hexagonal packing we can take a equilateral triangle in order to calculate packing fraction. So if I forget the formula of packing fraction of hexagonal packing, I can derive here. So in this equilateral triangle, packing fraction is area occupied. So there are 3 circles whose contribution is 1/6. Because angle is 60-degree equilateral triangle, so we can write that 3 into pi r square divided by 6. This is area occupied by the marbles upon total area. Total area is area of equilateral triangle, which is equal to under root 3/4 a square. A is equal to 2 times of radius of marbles whole square. So if we simplify in the numerator and denominator, r square will cancel out. So in numerator we'll get pi/2, and in denominator we are getting under root 3 because 4 and 4 will cancel out. So this packing fraction is equal to pi/2 root 3. Pi/2 root 3, which on simplification will get this value as 0.907. So now we are using the concept of packing fraction. We can say that packing fraction is equal to total area occupied. So we can assume that there are n marbles multiplied by area of one marble divided by total area. Total area will be area of square, total area. So from here, if we write that what is the value of n, n is equal to packing fraction into total area divided by area of one marble. So we know that when marble is placed and we take projection, it will look like a circle. So packing fraction we have calculated pi/2 root 3, and total area will be edge length square 40 into 40, and area of one marble is equal to pi r square. So pi, and the value of r is 5, so 5 into 5. So pi will cancel out. If on simplification we are getting here we are getting 32 by root 3. So if we simplify further, we are getting this value is equal to 18.47. So we are getting the same answer by the second method also, and I think that the second method is more easy, right? So if you like this video, please do not forget to like and subscribe it. Thank you.